At exactly 1 a.m. local time on September 13th, 2025, at Primorsk Oil Port, the largest energy export gateway for Moscow on the Baltic Sea, two giant tankers, Kusto and Kai-Yun, were entering the final stage of their fueling operation. Under the glare of industrial lights, hundreds of thousands of liters of crude oil surged through enormous steel pipelines, pumped straight into the cargo holds. Each ship had a capacity of more than 120,000 short tons, the equivalent of millions of barrels, and a single load like that was enough to sustain Russia's strategic export flow for days. To Moscow, they were not merely two ships, but floating vaults, keeping the very heartbeat of the national economy alive and ensuring energy contracts with Europe and China did not break. To Ukraine, they were the single most ideal targets across Russia's entire energy export chain. Strike here! It's nothing less than a gash into the veins of Russia's gasping war machine. And within just a few hours, a black gold treasure worth over 200 million USD will erupt into an unquenchable fireworks display. At 1:15 a.m., from a covert launch site in northern Ukraine, the first Lyuty AN-196 UAV screamed into the night like a ghost. Every 10 seconds after that, another took off. Within 7 minutes, the entire formation of over 40 UAVs had left their rails. They were like a pack of trained suicide hounds, programmed days in advance, each carrying a warhead of nearly 65 pounds of PBX-12, a thermoplastic polymer explosive variant with superior penetration, all directed at a single objective, Primorsk Oil Port. Rather than flying straight in, the swarm split into three main axes, forming a tactical pincer designed to deceive radar and fracture Russia's air defense response. Center axis, 20 UAVs, hugged the rail corridor via Belgorod-Voronezh, flying under 656 feet, completely avoiding ground radars. East axis, 10 UAVs, routed via Tambov-Ryazan, skirting areas hosting S-400 and Pantsir S-1 batteries around Tula, the no-fly high-priority zone for Moscow. West axis, 10 UAVs, followed the Belarus border, using terrain masking and deep forests to evade long-range Podsolnuk and Nebo-M radars. The entire UAV formation was controlled through the Skynode-S platform, a low-level artificial intelligence system integrating computer vision, high-resolution infrared cameras, and real-time digitized terrain maps. Even if GPS signals were jammed by the adversary, Lyuty's Skynode automatically switched to inertial/localized navigation, using imagery streamed from onboard cameras to match against the digital map. Power lines, transmission towers, forest contours, drainage channels, all were mapped by the AI as vital navigation landmarks. No radio signals were emitted, no remote control chatter was required, and that is why Lyuty becomes a nightmare. It is effectively immune to Russian electronic warfare. At 3:41 a.m., as the swarm closed on the Urzhev area, roughly 140 miles from the Leningrad border, Ukraine suddenly activated a trump card that had been hidden since the start of the operation. From a control center near Kharkiv, a Ukrainian low-Earth orbit reconnaissance satellite was steered into action. This was not a routine spy satellite. It had been modified to carry a false reflection module specialized to jam radars. Its sole function, temporarily neutralize the relay radar chain along the Smolensk-Tver-Novgorod line. This was the critical early warning belt in northwest Russia, the line that allows the Russian military to detect threats from Belarus, Ukraine, or the Baltic. Over the next 7 minutes, Podsolnuk, Gamma DE, and even Nebo-M radars were forced to process dozens of false returns from an electronic cloud moving in parallel toward the northwest. While Russia scrambled over the sudden flood of red blips on their screens, 40 real Lyuty UAVs slipped quietly beneath the sky, straight toward their true objective, the strategic Primorsk oil port. At 4 a.m., after nearly 3 hours of terrain-hugging flight, the entire UAV formation had closed to the Gulf of Finland approaches. less than 95 miles from Primorsk, when 5 UAVs from the center axis unexpectedly peeled off the main formation and simultaneously swung their noses up, climbing rapidly to 16,400 feet, turning themselves into bait in the sky. Each was fitted with a cluster of radar reflective panels and a signal emulation transmitter, accurately simulating the radar signature of a high-altitude strike package. In the eyes of Russian radar, these were no longer UAVs, but a real threat. At 4:08 a.m., on the radar screen at the Lezhnevo early warning station in Novgorod region, 5 unusual returns appeared. The returns were clear, stable, and exhibited strong reflectivity. Immediately, the alert level in the area was raised to level 1. Within less than 2 minutes, the sensor panel at the local Air Defense Command concluded unidentified targets, slow speed, low altitude, but with unusually high radar cross-section, likely reconnaissance UAVs or small aircraft. Committable to engagement. A firing order was issued at once. 2 Pantsir S-1 batteries in Yaroslavl launched simultaneously. 4 57E-6 missiles streaked into the sky. From Cherepovets, an S-400 battery fired 2 48N-6E missiles, Mach 6, covering the entire target intersection. Just 40 seconds later, all 5 returns vanished from the radar screens. Thermal data recorded multiple fragments falling into the forested area north of Novgorod. From the command post, the announcement confirmed 5 high-altitude intruding targets neutralized, no ongoing threat. But the Russian officers did not know that they had just shot down 5 sacrificial decoy UAVs, pre-programmed by Ukraine to be expended at this moment. The remaining 35 Liu-T UAVs skimmed close to the ground. Each was spaced 650 to 980 feet apart, maintained an altitude below 330 feet, emitted no signals, and returned no radar echoes, the entire operation relying on terrain mapping and inertial navigation. At 4:17 a.m., the central UAV formation crossed Lake Ilmen and pushed into the corridor between Novgorod and Leningrad. On Russian ground-based radar screens, everything remained utterly silent. No alerts were triggered. Beneath that veneer of calm, a nightmare was quietly closing in. At 4:22 a.m., the western wing approached the southern edge of the Narva Gulf, an area nominally covered by early warning radar posts and Pantsir batteries of the Leningrad military district. A faint blip began to appear on the Vyborg Air Defense Command's screen. The data was unclear. A fuzzy target, low speed, intermittent returns. An officer warned, it could be a flock of migrating ducks or a low-flying stealth target. But no one had yet given the order to open fire. The engagement order was being delayed. Nobody wanted to press the button first for something that might be a radar illusion. At the same time, the 10 eastern UAVs crossed the Onega Lake area and approached the Petrozavodsk-Vyborg rail line, one of the logistic arteries leading straight to Primorsk. The lead UAVs used a real-time terrain synchronization algorithm, constantly matching sensor data to a 3D map to slip through GPS dead zones that Russian electronic warfare teams had erected along the route. Infrared cameras picked up glints from radar towers, and the AI instantly adjusted course, avoiding each watch point as if it had flown the line hundreds of times before. At 4:27 a.m., when the first UAVs were less than 25 miles from Primorsk, Russian ground radar began to register real contacts. Numerous small targets hugging the surface, moving at moderate speed, converging from 3 different directions. At the Air Defense Command near Vyborg, the duty lieutenant colonel finally ordered, "Situation Level 2. Activate Pantsir S-1. Expand monitoring sector to the southeast and the coastline." But it was already too late. By the time the Pantsir radars swept the southeast sector, the 3 UAV formations, center, east, and west, were simultaneously closing in from all directions. This was no longer a single strike, it was a timed encirclement down to the second. Within 45 seconds, Baltic air defense controllers confirmed the worst. The entire UAV formation was heading straight for the Primorsk port. Russia's second-largest oil export hub. 6 Pantsir S-1 batteries were immediately ordered to fire. From the coastal woodline, the launch tubes rose like angry serpents and then simultaneously spat 57 E-6 missiles, roaring through the night sky. In the skies, the remaining 35 UAVs split into 3 prongs. Each kept an altitude under 200 feet, weaving between container yards, coastal rail lines, and petrochemical complexes. All were coordinated under the principle of the swarm, each UAV an independent entity, yet also part of the whole, constantly sharing flight data, adjusting its bank angles to match the leader ahead, and evading threats through Skynode's synchronized algorithms. By this moment, Russia's last defensive layer began to respond. Operators on a Pantsir S-1 battery shouted as the 1 RS-2E radar finally locked multiple targets. In less than 90 seconds, 25 UAVs were destroyed, half shredded by 30mm autocannons as they closed under 656 feet, the rest intercepted by 57 E-6 missiles at close range. But the final 10 UAVs were unlike any that had come before. They were the Alpha Wolves, each assigned independent targets, unique flight algorithms, and carrying heavy payloads reserved for killing blows. Now they simultaneously activated their terminal attack mode. Primorsk oil port had only minutes left to survive. At 4:44 a.m., the last 10 Lyuty UAVs dropped below 165 feet, skimming the sea surface to hide within clutter reflections as their Skynode's navigation suite autonomously redistributed their final attack routes based on preloaded target data. They did not strike the same point. They divided the critical nodes of Primorsk's entire operating chain. The first 2 dove straight at the port's operations center, which controlled all loading schedules, fueling processes, and satellite routing. Instead of a perpendicular run, one pulled a sharp climb from the left, then plunged nose first into a second-floor window, identified as housing the main server cluster. The blast all but severed Primorsk's brain. As flames burst from the upper floor, 2 other UAVs simultaneously struck the tanker Kusto moored at the southern pier. The first slammed into the engine room, wiping out the power station and halting the oil pumps mid-flow. The second came from starboard, ramming the main intake pipe, triggering a secondary explosion. Unfinished crude spilled across the pier, igniting in less than 6 seconds. At 4:45 minutes and 12 seconds, 2 more UAVs locked onto the tanker Kai Yun, an Aframax-class vessel like Kusto, preparing to connect its intake line for the final transfer. The first tore into the intake valve control room, the second into the forward operations cabin. A fire column nearly 100 feet high roared from the deck, a death torch against the Baltic night. As flames spread along the quay, 3 more UAVs swung toward pump station number 2, the hub regulating more than 35% of Primorsk's total export throughput. The first destroyed the main pressure compression array, the second punched through the roof into the flow control regulator, and the third tore into the input signal receiver. Within just 0.8 seconds, pressure across the pipeline network surged beyond safe limits. Then, a thunderous blast ripped apart the pumping station's roof. Black smoke, scorching heat, and twisted steel fragments clawed into the sky. Primorsk had lost its pump station. In just 2 minutes, the last 10 UAVs had struck the port's vital organs. 2 supertankers of over 120,000 short tons ablaze, the central pumping station obliterated, all power and coordination systems cut. Fires raged out of control. When firefighters arrived, temperatures at the pumping hub exceeded 1,830 degrees Fahrenheit. With no options left, authorities were forced to seal off the entire port. Satellite imagery showed Primorsk as a blazing scar more than 1 mile long, with 2 core infernos and 4 secondary fires. Russia later confirmed at least 2 tankers destroyed, the main loading line to offshore vessels halted, internal power grids damaged, and fuel exports through Primorsk disrupted for days. Under the shock of the strike, all tankers in the Primorsk Gulf were ordered to withdraw immediately, triggering cascading logistical delays. The international oil market wavered slightly on the news, evidence that Primorsk was not just technical infrastructure, but also a financial and political linchpin. On the morning of September 17th, Russia's Ministry of Defense officially admitted that Northwest air defenses had intercepted a long-range UAV attack near Primorsk, while insisting that most targets were neutralized. No details were given about the actual damage to the port, yet within hours, international OSINT channels, including GEO-confirmed, had geolocated the strike area through nighttime satellite imagery, thermal readings, and telegram videos. Western analysts concluded this attack marked a breakthrough in both range and precision for Ukraine's UAV force. This was no random tactic. It was a textbook execution of modern drone warfare. Swarm division, electronic jamming, deception, and simultaneous strikes from multiple vectors. The same playbook Ukraine had used to annihilate S-400 radars at Jankoy and Sevastopol. The raid cemented a strategic shift in modern war. With only a few dozen low-cost UAVs, each priced between $30,000 and $100,000, Ukraine pierced one of the densest air defense belts in northwest Russia. Meanwhile, Russia expended surface-to-air missiles worth hundreds of thousands of dollars apiece, deploying wide forces, and still failed to stop the main blow. The failure at Primorsk showed that even the most heavily guarded civilian infrastructure is not immune to UAVs when an adversary fuses AI, swarm logic, and tactical precision. Above all, it sent a message to the world: if Primorsk can be hit, nowhere else is safe.